Good afternoon. Can you hear me? How is COVID situation at your place? Let us say someone from Ahmedabad. Okay, so let us look at some of the questions which you may have been confused with by looking at the responses. How did you perform in the first internal examination? Are the marks out? Have you got your marks? So are marks as per your expectations? Okay, nice. So let us quickly first look at this and then we will talk about some of the issues which are pending. Uh, can you tell me which one of this is the correct answer? Data link layer provides services to which layer and data to which layer at the transmitter? So you are saying that it provides services to network layer and data to physical layer. Is there anyone else who is having a different answer? Okay, so that is the correct answer. The next one, data link layer provides services to which layer and data to which layer at the receiver? What should we write in this one? Network. That is true. Yes. Now here you are supposed to find out that how many bit errors will be detected by these three codes. Three codes are given to you: E2, 37 and C9. And this X sign is given before that. So we know that this is hexadecimal representation. So very quickly, can you please write equivalent binary of E2, 37 and C9 and compare how many bits are different in them? What is the Hamming distance between first and second code, second and third code, and third and first code? Please open the book and start writing it. E2, that means 11100010. Okay, between E2 and 37, what is the distance between E2 and 37? Keval is saying it is 5. All of you have got to do it. What is the Hamming distance between second and third code, Prince? Between second and third, what is the Hamming distance? 37 and C9. Yes. Please unmute yourself and tell me. Someone has raised hand. You can unmute yourself and say. So now, if the Hamming distance is 5, 4 and 7 between three pairs, are you all getting this? This is what Keval has written. Others? So the minimum distance between all the pairs is 4. So how many bit errors can be detected in this case? Yes, 4 minus 1, that is 3. So Prince, actually Hamming distance is 3. No, Hamming distance is 4, and that makes you detect up to 3 bit errors. Hamming distance is not 3, Prince. Hamming distance is 4, but you can detect up to 3 bit errors. So I hope there is no doubt in this. The next one, just one code is different in that. Instead of C, it is D. And we have to find out how many bit errors can be corrected in this one. So again, you will have to find out the Hamming distance. So between first and second pair, E2 and 37, that will continue to be same. So that is 5. Can you tell me what will be between 37 and D9? And I would appreciate if new names appear on the screen. We are discussing the fourth question at the moment. (37) and D9 is 6. Okay, Devansh, nice. So that is 6. And what about E2 and D9? Okay, so you have 5, 5 and 6. Are you all getting these answers? Is Hamming distance between these three pairs of the codes is 5, 5 and 6. So if this is the scenario, then can you tell me how many bit errors can be corrected? If you want to correct up to n bit errors, what should be the Hamming distance? No, Prince, it wouldn't be 3. Yes, that will be 2. 2d plus 1. So here, the Hamming distance is 5. Whichever is the minimum distance between all the pairs. All the pairs are different by at least those many bits, that is considered Hamming distance. So if that is 5, you can put that in the formula and find out the number of bits which can be corrected. It will be 2. How many of you got this answer correctly in the examination? 2 in this one, and in the earlier one it is 3. Okay, 1 is correct. Prince, what about you? At least have you understood that now? That is okay. See, the purpose of examination is that only, so that we get to think on the different lines. So if you are taking blindly the same codes, then it will be wrong because there was slight difference here. And you apply the same formula, then also it would be wrong. So you have to be vigilant and alert while attempting the answers. Have you understood this now at least? All of you? Feel free to ask me whenever you have any doubts. Now the next one, the network topology is given like this: M, N, O, P and Q. It is mentioned here that N sends data to Q. That means N is the transmitter and Q is the receiver. So while in this topology, data is traveling from the transmitter to receiver, how many network layer processes and how many transport layer processes will be active during the data transfer? So out of this 6, 3 answer you can very easily rule out because we know that always 2 transport layer processes will be there. What do you think will be the correct answer? Six and 2. Yes, and there would have been another correct answer as well if I had given that kind of option. Can you tell me what that would be? Not 8-2, Dev. No, not 8-2. 4-2. Yes. Yes. I hope Dev you understand, right? Because on the transmitter there will be only one process, at the receiver only one process. While at the routers, depending on how we pursue, 1 or 2 processes for the transmission and reception. So never 8-2. 8-2 is actually one of the options given here, Dev. So that is not the correct answer. But if there was 4-2 here, then you might be confused. However, that option was not there. So here you will have to go for 6 and 2. Now this was just to give you 1 mark. What is the answer of this one? This and this are the data units at the network layer and data link layer. Packet and frame. Yes. The next one, even though I thought that most of you would be writing this correctly, many of you have missed it due to the unit which is mentioned here. How many bytes long are the IP address, port address and MAC address? You already know that how long these addresses are, but it was mentioned how many bytes long are they. Yes, so the correct answer would be 4, 2 and 6. Many of you have written 32, 16 and 48. That would be correct if it was how many bits are there. What about this one? Which of the following are jobs of data link layer? What does data link layer do out of this? See, if you just write framing, that will not be correct. Okay, unless you mention all the possible options. Yeah, so it will be framing, error control and flow control. That is true. Many of you have written that A, B and D. That is true. So in this scenario, it would be framing, error control and flow control. If you write this 3, then you will be getting 2 marks. No, congestion control cannot come. Here we don't deal with congestion or traffic. Congestion control is not part of the data link layer. Congestion control is attempted at the network layer and transport layer. Similarly, you cannot write this, that data delivery to the correct destination. That is done at which layer? Network layer, true. No, Krishil, transport layer would be responsible for the process to process delivery or end to end delivery. When I say destination, we mean the host or the system or the correct computer, the correct IP address. That is what we mean by that. Okay, the next one. Which one of the following are generally part of header of a frame? So again here, there are chances that multiple answers would be there. Can you tell me? No, not except flow control. Flow control is not there, but there is something else as well which will not be there as the part of the header. No, not ABC. A and B, of course you are right. Checksum will be part of the trailer. Checksum or CRC or the mechanism which we use to verify whether the data is correct, that will be used in the trailer. Initially you will be having the source address, destination address and frame identifier. Frame identifier means it could be sequence number or some other way through which we identify that, like which frame is this the duplicate frame or fresh frame, that we decide by the sequence number. So frame identifier, this 3 will be part of the header. There is no data related to flow control actually in the header or trailer anywhere, and checksum would be part of the trailer. So instead of frame identifier, if I write sequence number, then also it would be there. Which one of the following is applicable for piggybacking? It is a method in which acknowledgement may be temporarily delayed, or it saves channel bandwidth. Acknowledgement can be hooked onto the next outgoing data frame. A timer is used while waiting for data. Yes, either you can write all of this or this 4. That is true. D is also true, Abhi. Because do you remember auxiliary timer? If we don't have data, then we start auxiliary timer or acknowledgement timer and we wait for data for a while. So that if data is going to come very soon, then we can combine our data and acknowledgement. So as most of you said, all of this is true, or you may write all of this. Feel free to ask me if you have any doubts so far. Everyone? Okay. Read the next one carefully. Now it is not directly related to any protocol or anything, but that is more like the common sense and how you apply the logic. So which one of the following is true for efficiency of the given channel? Distance between source and receiver is directly proportional to efficiency of the channel. Length of the frame increases, then efficiency will decrease. If we want to send some small frames, then stop and wait is a good choice. If error rate is very high, then go back and is the protocol which should be used. Or none of this. Which of the statements are true? Let's discuss one by one in case if you are confused. Okay. See, distance is directly proportional to efficiency of the channel. Is it true or not? Like it is saying that if the source and receiver are far away, then the efficiency will be higher. Is it so? Like as you keep increasing the distance, efficiency will be better. Is it so? No. Yes, that is false. The next one says that if we increase the frame length, then efficiency will decrease. If we increase the frame length, then efficiency will decrease. Okay, then should we keep frame length as 1 only? In that case, best efficiency will be achieved. Let us have the frame length of 1 byte in order to have the best efficiency. Do you agree with that? No. So it is not so that if frame length increases and efficiency will always decrease. That depends on what is the frame length and what is the header length. If your frame length is so less that headers are overhead, in that case efficiency will be decreased if the length is lower. While if you increase the frame length beyond a point, then there are chances of error and retransmissions will be there, then again efficiency might be decreased. So that depends on up to what length you are increasing that, and then efficiency will be decided. So we cannot make a blatant statement like this that length of frame increases, then efficiency will decrease or increase. Both of that is going to be true or false. This is not a correct statement. Do you understand that now? Okay. What about the next one? If we want to send small frames, then stop and wait is a good choice. Is it so? Not really, right? Because if actually 50% efficiency is only there. So if you're going to go for the small frames, then you will be having the time to generate the frame, calculate the checksum, build a frame, sequence number, etc. At the receiver, you will receive the frame, you will verify data integrity, acknowledgement will be generated. So it might not be worth for the tiny frames. So we cannot actually say that if you want to send small frames, then stop and wait is a better choice. Intuitively also, I think you can fill this. And the last one, I would like one of you to give me the justification for the last one. If the error rate is very high, then go back and protocol is a good choice. Is this statement true or false? First tell me that, and then why so? Yes, that is false. true, because if error rate is very high, then there are chances that one of the frames will be corrupted. And whenever one of the frames is corrupted, then in case of go back in protocol, yes, exactly, we will have to send bunch of the frames. That means so many frames will be retransmitted whenever there is one of the frames failing. So that is not a good choice. So here correct answer would be none of this. In this one, the correct answer was none of this. Actually, none of the statements are correct. They are ambiguous statements and they depends on what are the other parameters. Then efficiency will be decided or frame length can be decided and so on. Okay. So the next one, this surprisingly many of you got incorrectly. I thought most of you would be getting this correctly, but many of you left it probably halfway. You didn't think it properly. So it says the transmission channel experiences 10% packet loss due to noise. So there is errors on the link and 10% of the packets which you send will be dropped. How many frames will be resent by the transmitter to transfer 400 frames if stop and wait protocol is used? So when you send 400 frames, how many frames will be dropped out of them? 40. Right. And when you are sending this 40 frames, then again your channel will be having the same characteristic, 10% of the frames will be lost. So out of this 40, again 4 will be sent. So what do you think should be the answer to this? Yes. How many of you written 44? Most of you have written 40 only, I think. Most of you have written 40, that 400 frames. So 40 will be retransmitted. Frame loss. Frame loss. Packet loss is a terminology which is very frequently used to indicate that how much data will be lost. So that is frame loss only. So how did it confuse you, Krishil? Did you interpret a packet and frame differently here? So one packet is equal to how many frames, or how did you interpret that? Tell me. Actually, it is a widely used terminology. That is okay. Yes, it takes time. Of course, it will take time. And in the class, we are very careful to use the appropriate term, but in general, these are interchangeably used. So this time, I have written that. However, I have given a hint here how many frames will be this, so that you will not be, again you will be back on the track. Like if you have to transfer 400 frames, then how many of them will be resent? So anyway, now you understand that how many of them will be resent, then your answer is going to be 44. If I say that how many total number of frames will be sent in this scenario, then what should be your answer? Yes, nice. Then it should be 444 because 400, then 40, and then 4. Yes, exactly. In generally, the practice is like this. If it was 600, then can you tell me what will you write? If it was 600, then how many frames will be retransmitted if there were total 600 frames? Then you might probably want to think here again whether it is 66 or 67. So that depends actually, that like 60 frames and then 6 frames. So if it is more than 0.5, then in some of the examples they do consider as the full frame. So they say then more frame will be there. If it is less than 0.5, they truncate it. In this type of questions, most of the time you will be having the options, and based on the option, you can accordingly choose it. Whether you want to truncate it or you want to go for selling or rounding function, based on that, the answer will be there. What will be the buffer requirement at the transmitter if sequence number is 4 bits long in two protocols, go back in protocol and stop and wait protocol. Can I please hear from one of the girls answer to this one? Will any girl answer this? That what should be the buffer size at the transmitter? For go back in protocol and for stop and wait protocol, and the situation is given to us that sequence number is 4 bits long. Birwa, Riddhi, Kanal, Aneri, Khushi, Neha, Heli, Shweta, Nandini. Anyone? Seriously? Is it that difficult? Okay, roll number 1 to 50. Anyone from roll number 1 to 50? Would you try this? We have got two answers, 15 and 1 and 16 and 1. Please think and tell me. So I like that at least you are getting 1 in the stop and wait. There you are not confused. What should be the buffer size at the transmitter? 16.1 or 15.1? Okay. Ideally, what should be the buffer size? Those many frames which are going to keep outstanding. Maximum unacknowledged frames which your sender can hold, those many buffers will be required. Because you might need to retransmit any of these frames if the acknowledgement is not coming within time. So in different words, I am asking here that if your sequence number is 4 bits long, then what should be your sender's window? How many maximum frames are you allowed to send? Yes, 15. So what should be the answer here? 15 and 1. 15 and 1 would be the correct answer. Now this one, I want all of you to do this, attempt this. And then of course I'll verify that as well. But I want all of you to do it. And please try to do it in 2 minutes. Please remember that when I say 2-bit sequence number is there in go back and protocol, then how many frames are we keeping outstanding? 3. Yes, nice. So maximum 3 frames will be outstanding. Every 5th frame is dropped by the network. So whether that is a retransmitted frame or that is the fresh frame, every 5th frame, if it is a 5th frame, then it will be dropped. That is what we are assuming. Of course, that is quite an unrealistic assumption, but still. And no acknowledgements are ever dropped. So you don't have to deal with the cumulative acknowledgement. I'm making your life easier here. How many total number of frames will be sent by the transmitter in this scenario where we are supposed to send 10 frames? Please do not write the answer based on what you have written in the examination, but I would rather want you to do it fresh right now and then tell me. Take 2 minutes and please give me the answer. Have you got the answer? Any one of you? Okay, everyone, please write down your answer freely. See, uh, look here. Everyone, please pay attention here. This type of questions are very frequently asked in the GATE examination, mostly of 2 marks. And once you know the concept, which you already do, I believe, if you patiently deal with this type of questions, there is not at all difficult to attempt. So we are not getting into the complexity of reusing the sequence number at the moment. We are not reusing the sequence number at the moment to solve the example quickly. You may do that afterwards, but currently we are not going to reuse the sequence number. However, the restriction which 2-bit sequence number will bring, that of course we have to follow. That at no point of time more than 3 frames should be outstanding. That is what your 2-bit sequence number is telling us. So initially I'll be sending frame number 1, 2 and 3. Not frame number 1, 2 and 3. Let us have first frame, second frame and third frame. Actually the sequence number would be like this: 0, 0, 0, 1 and 1, 0. I'm going to ignore the parenthesis now onwards. We'll be just focusing on that we will be sending first frame, second frame and third frame, and then we will stop. Do you agree with me? Because we have 2-bit sequence number, so you should never send more than 3 frames. So we have sent this 3 frames. Now what will happen in the usual scenario? Your receiver will get first frame, it will send acknowledgement of that, it will receive second frame, it will give acknowledgement of that, it will receive third frame, it will give acknowledgement of that. What will happen at the transmitter? I'll get acknowledgement of 1. When I get acknowledgement of 1, I know that it has been delivered. That means I can send the next frame. Then I'll get acknowledgement of 2. That means I know that it has been delivered, so I can send next frame. At no point of time more than 3 frames will be pending. Then 3 was also delivered, so I'll get an acknowledgement of that. I'll send 6. Now the data is traveling. 4th will be delivered, but 5th will be lost. We said that every 5th frame is lost. It will be lost. What will happen at the receiver? It is getting 4th frame correctly. So will it generate acknowledgement of 4th frame? Yes, it will generate acknowledgement of 4th frame. So here at the transmitter, I'm getting acknowledgement of 4th frame. That means I'm clearing the buffer. Yellow means it has been delivered. I'm clearing the buffer. And now I'll send frame number 7. Because 3 frames can be outstanding. I don't know what happened to 5. I have received acknowledgement of 4. In the moment I receive acknowledgement of 4, I'll remove 4 from the buffer. I'll send 7 against that. Now what will happen at the receiver? 5 is lost. That means receiver is waiting for 5th frame. It will not get that. So it will keep waiting for that frame only. 6th will come correctly. But will receiver accept it? This is go back and receiver. 6th frame is arriving correctly at the receiver. But 5th is missing. Will receiver accept frame number 6? No. No acknowledgement will be generated. Similarly, 7th, even though that is correct, because it is out of order, it will be rejected. Now what happens at the transmitter? Come on, let us do this together. Yes, timeout. Timeout of frame number 5. Yes, Ronak, that is true. Frame number 5. That means I'll be again sending 5, 6 and 7. All the pending frames will be resent. So we are going to retransmit 5, 6 and 7. Remember the rule. What is the rule? 1, 2, 3, 4 and 5. The 5th frame will be dropped. Now what happened at the transmitter? This 6 and 7 were rejected by the transmitter. This was lost. And this is rejected by the receiver. This one was also rejected by the receiver. Receiver was waiting for 5. When 5 is received there, it will be happy and it will accept it. And at the transmitter, we will get acknowledgement of which frame? Frame number 5. We'll get an acknowledgement of frame number 5. So I'll be sending frame number 8 because 3 frames should be outstanding for optimum performance. Now receiver is received 5. It is getting 6, which is also correct. So acknowledgement of 6 will be generated. 6 is also delivered. So what will I do? I'll send 9. Now receiver 7, it is not getting. 7 is not reaching the receiver. 8 is reaching, but it is rejected by the receiver. 9 is also rejected by the receiver because they are out of order. Even though they are correct, they are out of order. Now tell me what will happen at the transmitter. Yes, your transmitter is again going to send 7, 8 and 9 whenever there is a timeout of 7. Now which frame? While they are traveling, this is the first frame for the network, second, third, fourth and fifth. So this will be dropped. Receiver is waiting for 7. 7 is delivered. You are getting an acknowledgement of 7. So we'll be sending 10. 8 has been delivered. We are getting an acknowledgement of 10. Should I send 11? I'm getting acknowledgement of 8. No, because maximum 10 frames are to be sent. If we were supposed to send 12 frames, then I'll be sending 11 as well. But now, that's it. And now receiver is waiting for 9th frame. But that is lost. 10th will be rejected by the receiver. So what will your transmitter do? Well done. Whenever there is a timeout for 9th, it will be retransmitting 9 and 10th. And now this is 1, 2 and 3. So these frames will get through. So can you tell me how many frames total are we sending in this scenario? What is the correct answer here? Yes, 18. 18. How many of you have written 18? Some of you have written 18. Some of you written 20. Somehow you have missed it. And then of course there are variety of answers. Starting from 10 to 20, I have got variety of answers. Like many of you have written 18. So anyway, if you had not written that, that is okay. This is the method which we will follow. Would you like to do another example like this? Let us do one example and that will go back to some of the points which are missed in the data link layer. So let us say we are using 2-bit sequence number. The message is of 12. Let us keep it 10 only. In every 4th frame is lost on the network. Everyone, please start doing it. And hopefully at least more than 60% of you will be giving me the correct answer this time. Please solve this. Let me make it 11 just for a change. Okay, 11 frames. Every 4th frame is lost and 2-bit sequence number is used. I know that you are still doing it, but are you getting any idea? Will number of retransmissions, will number of total frames increase or decrease in this scenario? Total number of frames which we'll have to send, will they increase? Yes, yes, they'll increase. Increase for two reasons. Because the here every fourth frame is lost. In the earlier scenario, every fifth frame is lost. And if you observe a pattern after some time, it will so happen that after fourth, almost all the frames will be dropped. Like fourth will be dropped, then after some time fifth will be dropped, and so many retransmissions will be there. Palna, let us wait for some time. I don't know actually how runtime given this example. So let us wait for other answers, and then if required, we'll do it. But your number seems likely. It seems likely. It is not unlikely, not much out of the range. So Devansh, Ayush, Janil, everyone, please do it. And once you are done, give me your answer. Okay, some are getting 31. I'll still wait for half a minute and then we'll do it. Palna, by looking at the majority, I would ask you to please look at your data again. You might be right. It is not so that you will be wrong, but still, would you please go through that once again? Acha, you calculated for 10 frames. Oh, yes. Here there are 11 frames. I'm also getting 31. So it seems that because you are saying 31, I'm also getting 31. It should be the correct answer. Is there anyone who is getting a different answer? And see, here the thumb rule is that whenever retransmission is attempted, if there are data to be sent at the transmitter, then full window would have been exploited, like 4, 5, 6. If it is 5, then 5, 6, 7. If it is 7, then 7, 8, 9. All of them will be outstanding. So you don't need to actually think about like receiver has received this now, in response to the transmitter has sent it next, and so on. Even if you do that, that is correct. In fact, that is the way it would be working. But you can also think that if there are 11 frames, then transmitter will always send the sender's buffer until it has 11 frames delivered. So if 2-bit sequence number is there, then always 3 outstanding frames will be there. So whenever there is a retransmission, then that retransmission and next 2, these 3 will be retransmitted. So if you think like that, then quickly you should be able to get through the problem. So will you be able to solve this type of examples in future? And not just sole example, I hope this is also giving us a very clear idea that as such 11 frames were there. In every 4th frame is dropped. That means from this 11, only 3 frames are dropped. But still, if you are using go back and protocol, then we are ended up sending 31 frames. 3 times of frames are sent if we are using go back and protocol. So it is not an attractive and useful protocol for the real life applications. We did realize that, but now it should be clearing it all the more clear. So now the same question could be there for the selective repeat protocol also. But if it is for selective repeat protocol, then you will see that only frames which are sent, those will be retransmitted unless the special scenario is there. And then number of retransmissions will be lesser, number of total sent frames also will be less. And if I say that loss is applicable in both the directions, like for the frames and for the acknowledgements, then the effect would be different. Can you tell me, will number of total number of frames be same or less or more in that scenario? Rather than dropping frames just from the forward link, if we drop, let us say 4th frame, let it be frame or the acknowledgement. If every 4th is dropped, then will number of total frames be 31 or lesser or more? I don't want you to calculate it and invest time, but intuitively you should be able to figure that out. Priyank says more. See, please remember that if acknowledgements are dropped, they might not harm you as much, because we are dealing with the cumulative acknowledgement. Like if you are sending 1, 2, 3, 4. Okay. So if I say 1, 2, 3, 4, then in the reverse link, we'll be having acknowledgement of 1, acknowledgement of 2, and acknowledgement of 3. So which is the first frame dropped? Your first frame dropped is going to be this acknowledgement of 1. But when your transmitter is getting acknowledgement of 2, it knows that 1 has been delivered, 2 has been delivered, 3 has been delivered. In this scenario, then the frame which will be dropped, 1, 2, 3 and 4 will be 5th. The acknowledgement of 1 which is dropped is not adversely affecting the number of transmissions, because when your transmitter is getting acknowledgement of 2, it stops timer for 1, it stops timer for 2. It sends 4 and 5, because it knows that 2 would be accepted only if 1 was also there. So if I'm getting acknowledgement of 2, that is a clear indication of data delivery of frame number 1 and 2. So your 5th frame will be dropped. Are you with me? So not necessarily more. Okay. I would bet my money on having less number of or total number of frames in this scenario, because here the chances are that some of the acknowledgements are dropped and some of the data frames are dropped. If acknowledgements are dropped, they are not going to harm us unless it is a third acknowledgement. Like here, if it was a third acknowledgement, then there will be a timeout for that one. But if it is first or second acknowledgement, then it will be indirectly covered. And you can see it here also, like 4th was dropped. That means 4, 5 and 6 were retransmitted. But in this scenario, first data frame which is affected is 5th. That means 5th, 6 and 7 will be affected. However, we cannot confidently say anything unless we solve this, because much would depend on which number the frame is dropped, Is it causing more of the time last acknowledgement or first or second or which one? Anyway, but I hope you found this interesting. And if you have no doubts in this, I would like to talk about something else. Are we fine so far? Okay, fine. So now we had discussed selective repeat protocol. I have asked you to go through listing of that. But again, I would ask the same question which I have asked in the go backend protocol. That if we are using 3-bit sequence number, then what should be the sender's window? What is sender's window? Sender's window is how many frames should we send and then we should wait for the acknowledgement. Pending unacknowledged frames, maximum number of frames which we can send. 7 was the answer in go backend protocol. Yes. Do you think we'll be able to use the same window in selective repeat? Is it always 1? Is your receiver's window 1 in case of selective repeat? No, Priyank, it isn't 1. So what is the window? Acha, you are saying 7. Others in general, forget about 7 or any number. What is the receiver's window in case of selective repeat protocol? Same as the transmitter's window. Whatever is the sender's window, the same will be the receiver's window, right? So now, I would have expected you to work with the situation which we faced in go backend protocol. That if you are sending, let us say 7 frames, okay, that means you are sending 1, 2, 0. Can I please go for 2-bit sequence number so that example will be easier? So the range would be 0, 1, 2, 3 if you are having sequence number 2-bit. But because you are suggesting 2 raised to n minus 1, I'll be sending 3, 0, 1 and 2. Receiver is also having window open for 0, 1 and 2. It will accept 0, 1 and 2. And now what is receiver expecting next? Receiver has received 0, 1 and 2. Now what is receiver expecting next? Not 3, not 0, 3. Receiver is expecting 3, then 0 and then 1. Like this is frame number, first frame. This is the second frame. This is the third frame. Receiver has received first frame. Receiver has received second frame correctly. It has also received third frame correctly. Now receiver is waiting for fourth frame, which should be having sequence number 3. Then it is waiting for fifth frame, which is having sequence number 0, and sixth frame, which is having sequence number 1. Are you with me so far? Okay. Now let us go for the old bad situation which we faced. All the acknowledgements are dropped. 0, 1 and 2, they were accepted. First, second and third frame. They were accepted. Acknowledgements were generated. But unfortunately on the reverse link there was burst error and link disconnection was there momentarily. All the acknowledgements were wiped out from the channel. So what will happen at the transmitter? Timeout. Yes. Timeout for what, Ronak? Timeout for which frame? Yes, first for 0, then for 1 and then for 2. Because all the acknowledgements are dropped, we will experience timeout for all the frames 0, 1 and 2. So what will your transmitter do? Your transmitter is dealing with the responsibility of sending the reliable communication. It is it has agreed for the reliable communication, so it is going to retransmit frame number 1, frame number 2 and frame number 3. Now your receiver will be getting this 0 first. So what it will assume? That third probably is lost on the way, and fourth frame, which should be having sequence number 3, is lost. However, I'm getting 0. It would first would not be written there, only 0 will be there. So it will say that okay, I'm selecting repeat and I should store that frame here if it is coming out of order. That means your first frame is treated as the 5th frame. This frame, second frame, is treated as this frame. It will be stored here. So when it receives frame number 2, then it will say that no, I'm waiting for only 3, 1 and 3, 0 and 1. Between function will be telling that this is not a valid frame. So it will be rejected. So these 2 frames we have misinterpreted and we have taken incorrectly is frame number 5th and 6th. However, they were first and second frame. So this is not being reliable. If you are using sender's window as 2 raised to n minus 1 in 2-bit sequence number, if you are using the window of 3, we are having this trouble. So what do you think should we use for 2-bit sequence number? If I use only 1, if I use sender's window is only 1, will it work? If the sender's window is kept only 1 and receiver's window is only 1, then will it be reliable? Yes, it will be. But that will be then just like stop and wait protocol. There will be no advantage of select repeat protocol. Can I go for 2? Can I have sender's window 2? Do you think sender's window 2 will ensure reliability? I think that should work, because let us say receiver has first sent 0 and 1, transmitter has sent 0 and 1, receiver has received them. So now receiver is waiting for next 2 sequence number 2 and 3, and we are going for the same example in which all the acknowledgements are dropped on the reverse link. The acknowledgements are dropped on the reverse link. So at the transmitter, we will have timeout for 0 and 1. We are retransmitting 0 and 1. So what will your receiver do? Receiver will say that no, my window is open for only frame number 2 and 3. The 0 and 1 are not accepted. So there will be no duplication. There will be no confusion between the retransmissions and the fresh frames. Are you with me? So can you generalize this, that if the sequence number is n bit long, what should be the sender's window in select to repeat protocol? I am awaiting the last answer and then we will end the class. Like in go back in protocol, if the sequence number is n bit long, your sender's window should be 2 raised to n minus 1, 1 lesser than that, which will protect us. Here, okay, yes, Kevin, that is true. 2 raised to n minus 1, or I could say 2 raised to n divided by 2. Would you say the same thing? You may write it like this or like this. Yes, Ronak, you are also right, and Kevin is also right. So here, what are we doing? The idea is simple, that use half the window only. If your sequence number range is 3-bit sequence number, so 8, then send first 4. So even if 4 acknowledgements are lost, then receiver is waiting for the next 4, and there will be never any confusion between the current window and the previous one. At no point of time, because the retransmissions in the previous window are not overlapped, and hence there will be no confusion and it should work just fine. Please try to do it at your place. Any example, you can lose any number of data frame or acknowledgement, and it will be able to ensure reliability. Thank you.